Hello friends, welcome back to KSS, Kindle Science Station, which is all about loving science, kindled through toys and objects around us. Today I have a very interesting topic for you, which will unfold the secret formula adopted by nature, called the Fibonacci's number or sequence. Named after the Italian mathematician Leonardo Pisano, who was also known as Fibonacci. In this sequence, each number is created by adding the previous two. If we start with initial default numbers 0 and 1, when we add these 0 plus 1, we get 1. Adding 1 plus 1 gets 2. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. And so on. Let us see how these numbers are linked to nature. The spring is around and you will see many flowers blooming with colorful petals. Do you know the Fibonacci's number or sequence that we just saw can be applied to many species of flowers in relation to the number of petals we see in them? Observe and count the number of petals in the flowers around you. You can avoid plucking them and count them attached to the plant. You will be surprised to see the miracle of science as well as the beauty of nature. The number of petals usually follows the Fibonacci series. They will count 2, 3, 5, 8, 13, 21. So let us see some examples. These are 5 fused petunia flower petals. So next time when you are admiring the beauty of flowers and nature, have a closer look and you might see the miracle of science linked to the Fibonacci's number. Let us make another picture showing Fibonacci's number using squares. We start with two small squares of size 1 unit next to each other. On top of these, draw a square of size 2, which is 1 plus 1. We can now draw a new square touching the last two squares of 1 and 2, having sides 3 units long, and another touching both 2 unit square and the 3 unit square. We can continue adding squares around. Each new square having a side which is long as the sum of the last two squares. These sets of square which are made according to Fibonacci's number is finally called as a Fibonacci's rectangles. Here is a spiral drawn in the squares, moving quarter of circles in each squares. Though the spiral is not a true mathematical spiral, but it is a good approximation. You know, such spirals are seen in many shapes of nature. If you closely stare at the center of a sunflower, you will notice that its center is not just comprised of thousands of randomly grouped seeds. Instead, you will see a pattern emerging of a several clockwise and anti-clockwise spirals. Now try to pick out the spirals that are formed by the positions of the seeds in this black and white sunflower image. Far from being just a pretty pattern, this formation follows the Fibonacci's number. Similar to the spiral shape we saw with the Fibonacci's rectangle. So why the nature loves the Fibonacci's number? In case of sunflower, this allows for the maximum number of seeds on the seed head. So the flower uses the space to the optimal effect. Fibonacci's number also reveals themselves in the spiral of a rose bloom. Like the sunflower seeds, the arrangement allows for the most compact containment of the petals. Just think of a size of a rosebud in comparison to its fully opened bloom. So now you know the reason why nature loves Fibonacci series so much. Let us see some more examples. This is a cauliflower. If you see closely, the florets are organized in a spiral around the center in both directions. Isn't that so amazing? So next time when you buy or make its vegetable, do remember its Fibonacci's connection. The Fibonacci sequence can also be seen in the way tree branches form or split as they grow. Also, many plants shows the Fibonacci's numbers in the arrangement of the leaves around their stems. If we look down the plant, the leaves are often arranged so that the leaves above do not hide the leaves below them. This means that each leaf get a good share of sunlight and catches most of the rain in the channel down to the root as it's run down the leaf to the stem and finally to the roots. Now let us understand what is a golden ratio in a Fibonacci's number. Remember we studied the Fibonacci's rectangle. The sides of this rectangle has a proportion to each other, which is in the ratio 1 is to 1.618. That means if we take the ratio of the two successive numbers in a Fibonacci series, we get the ratio which is approximately 1.618, and this approximation is more closer for a bigger numbers. My son had collected these sea and river shells over the years. I found most of these had a spiral structure and found as the insect living in these shell grows, it periodically seals off the shell behind it and creates a larger living chamber. The growth process yield an elegant spiral structure. I tried to calculate the ratio of the inner and the outer spiral to find its golden ratio. I was surprised to see the ratio was always 2 between the two successive spirals. It was quite close to the ratio we saw in the Fibonacci's golden ratio. So friends, look around you and find what all other objects you can find in the shape of a spiral. You may find a snail shell. Look, I could find this small snail shell in my garden. Shape of certain spider webs are also spiral. Horns of certain goats are in a spiral shape. So, mention in the comments what other shapes you could find arranged in a spiral shaped around you. Hope you enjoyed watching the video. Do give your valuable comments and do not forget to subscribe and press the bell icon to get the notification of my upcoming videos. Bye for now. Till then, keep kindling your thoughts by observing the things around. Take care and see you soon.